Okay, let's talk about object-oriented programming. There are a lot of videos on YouTube explaining OOP in detail, and that is not the intent of this video. The goal here is to simply give you a very brief overview. I want to introduce some of the main concepts so that when I refer to them in other videos, you have some context for what I'm talking about. For example, I don't want to talk about private variables if I haven't explained basically what encapsulation is first. So as a scientist, you may be more familiar with procedural programming. For example, Fortran. Procedural programming does exactly what it sounds like. It proceeds from one step to the next. Object-oriented programming treats everything as an object. So rather than simply being a set of instructions that go from beginning to end, you take all those different instructions and attributes and variables and you encapsulate them into objects. Now Python is both procedural and object-oriented. It's called multi-paradigm. Now I'm not here to tell you which one is better or worse as a hard rule. Whether you write procedural code or object-oriented code should really be a function of what exactly it is you're doing. But I will say in general, in my opinion, object-oriented code is superior to procedural code as a general rule. And there's three main reasons. It's significantly easier to maintain, it's significantly easier to test, and it's significantly easier to tune. So let's talk about the four main principles of object-oriented programming. And they are encapsulation, abstraction, inheritance, and polymorphism. Now, as I said, there's lots of information on the internet if you want to know the intricate details of all these. Unfortunately, you're not going to find a lot of consistency. The general principles are often the same, but everyone has their own take on exactly what these four terms mean and how much of it's applicable, how much of it's beneficial, whether object-oriented design in general is beneficial. It seems like everything in programming is filled with controversy, and OOP is no different. So what I'll try to focus on is the practical application of this in Python and the code you'll write for the 16th Weather Squadron. Encapsulation. It's the idea that you keep the data and the functions that manipulate that data together. In Python, we refer to these objects as classes. Data are properties, and the functions are methods. The reason we care about encapsulation is that it includes something called data hiding. There is no real consensus on the internet if data hiding and encapsulation are synonyms, or if data hiding is part of encapsulation or one way of implementing encapsulation. But this is where the general principle of private variables comes from. The idea that things outside of your object should not know about the internal properties of your object. They should be private. Abstraction. I think the general consensus, at least practically speaking, is that abstraction means I don't need to know how your object works under the hood in order to use it. All right, to demonstrate this concept, let's think of a very simplified view of a car in which I put gas in, and when I press the accelerator, it moves forward. What happens underneath is abstracted from me. I don't care about the combustion engine or a carburetor or fuel injection. None of those things are my concern. All I care about is the interface to put the gas in and the interface to make it move. That's abstraction. Encapsulation is the gas in the tank. I don't pour the gas directly into the tank. There's a process that goes into that, and any safety features involved aren't my concern. That's handled by the car. Likewise, if I want to know how much gas is in it, I don't look directly in the tank. I'm provided an interface to see how much gas there is. So the gas inside the car is encapsulated. It's hidden from me. The abstract part is how I interface with it, and then what happens to that gas. The gas goes through some process that makes the car move. That's abstract. I don't care. I just need the interfaces. Inheritance is much easier to explain. Essentially, you have parent classes and child classes, and those child classes that derive from the parent should inherit the parent's class properties and methods. And for this, we have the old standby. If I have an animal class, I can create child classes of this for a dog and a cat. And all of the animals might have names and sizes and methods for feeding. All these methods that get defined for an animal should also be available for dog and cat. They inherit those methods. Same thing with any properties that might be in here. They automatically go to the child classes. Polymorphism, on the other hand, is a little bit more difficult to explain. Now, the precise definition is the ability to take various forms. But practically speaking, what does that actually mean? Well, you could say it's the ability to override an object's string or length methods. Or you could say, as in our previous example, it's the ability to override the parent method in the child class. Ultimately, what we care about for this series of tutorials is how all this relates to Python. And I will cover Python classes explicitly in a separate video. I will not, however, include any additional links below in this video. In my opinion, there is no definitive source. There are no links I found that I feel comfortable sharing to say, for example, this is exactly what encapsulation means, or this is exactly what abstraction means. I think for our purposes, I just want to introduce the general concepts so that in the next video, I can talk about Python classes and how to use them.